Good morning. This is Dr. Sasikala. Today we are going to have a session on variation of parameters. It is used to solve second order differential equation. So variation parameter is used to find particular solution or a particular interval, we can say. It can be found out for non-homogeneous linear differential equation. So for that one, first we have to know what is a homogeneous. Homogeneous means the right hand side becomes 0 for a differential equation. So here, right hand side we can denoted as r of x. This can be a function, a constant, or any trigonometric function also. We can solve using the variation of parameters. So how will you solve? Basic idea is, you'll be finding the complementary function yh. Then once you got the complementary solution, you'll be assuming C1 and C2 as a function, and we will assume particular solution yp as u1 y1 plus u2 y2, where yu1 and u2 are this formula. We'll apply this formula, and here the w is denoted as Wronskian. Wronskian formula is determinant of y1 y2 y dash y2 y dash. So this is the problem we are going to solve for today. Y double dash minus y is equal to e power x. So now we will solve this problem. So for this equation, first we'll be finding the auxiliary equation. Or here, y double dash, we don't have any question. Directly we can write it as m square. And here you don't have coefficient, so we can write it as 1 is equal to 0. You have to find the root of this equation, which is nothing but m square. It becomes to left hand, right hand side means it becomes 1. M is equal to plus or minus 1. So now complementary solution, we have to write the formula. What is the formula for this one? Anyone can tell me what is the complementary solution formula? Complementary solution formula is here roots are unequal, and it is real. So we can have a formula for this one as yh is equal to c1 e power m1x plus c2 e power m2x, where m1 and m2 are nothing but plus 1 and minus 1. So you'll be having the root as c1 e power 1x can be written as x, and c2 e power minus 1x we can write it as minus x. So we will assume this value as y1 and this as y2 and find what is the Wronskian. So we'll assume particular solution as yp is equal to, by formula what I said, c1 we will assume some function u1 and e power x I'll assume it as y1, and c2 is another some function u2, and here e power minus x, e power minus 2x we can write it as, y2. So what is y1? y1 is nothing but e power x, and y2 is nothing but e power minus x. So what is Wronskian formula? Wronskian formula is nothing but y1, y2, y1 dash, y2 dash. So determinant of this value you have to find. So y1 is nothing but e power x, and y2 is e power minus x. And what is the differentiation of e power x? E power x differentiation is e power x, and e power minus x differentiation is minus e power minus x. Now what we are going to do is just cross multiply these two terms. So we'll be having e power x into e power minus x minus, here already you have a minus n, so we'll be having minus of e power x. Again here if you see means e power x into minus e power x, so the answer is e power x into e power minus x. So minus, here exponents in multiplication, both the exponents are common, so we can add the terms. So we'll be having e power x minus x minus of e power x minus x. So the value is e power 0 minus e power 0. Sorry, 0. So which is equal to e power 0 value is what? 1. So we'll be having minus 1 minus 1. So you can add the terms, you can get it as minus 2. So what we have found? Auxiliary equation we have found out and found the complementary solution. Once we have found out the complementary solution, we have assumed yt as u1 y1 plus u2 y2, where y1 and y2 are nothing but the complementary solution function. And here with that one we have found what is here Wronskian value, which is equal to minus 2. Now we are going to find what is u1 and u2. So u1 formula, as I said already, we have written as u1 is equal to this one. So just apply the value. So u1 is equal to integral of minus y2. y2 is nothing but e power minus x. Now we got now that value. And r of x. r of x is nothing but right hand side value, which is e power x. So we'll be having e power x. Wronskian value, now only we got it as minus 2 dx. So this is equal to minus and minus gets cancelled. So e. And here the same thing. Here again e power x into e power minus x. So it becomes e power 0. So we can write it as plus 1 by 2 dx. So which is equal to, what is the answer? Integration of dx constant, you can write as it. Integration of dx is nothing but half. So plus 3 you can write it as. So next, what is u2 you have to find. So now what is y1? E power x. Rx we have, what is Rx value? We have e power x. So e power x by Wronskian value minus 2 we got dx. So which is equal to integral. Here both the powers are same. So x plus x becomes 2x. So e power 2x. Here we can write 1 by minus 2 dx. So which is equal to minus 1 by 2. Integration of e power 2x value is e power 2x by 2. So which is equal to, what is the value? Minus e power 2x by 4. So you got y1 and y2, sorry, u1 and u2. Now, what is the particular solution formula? Particular solution is yp is equal to u1 y1 plus u2 y2. So which is equal to u1 we got it as constant, that is not needed. So I can write leave as such 1 by 2 x. And y1 you got answer as e power x. And u2 value is what? So u2 is e power minus 2, sorry, e power 2x by 4, or you have a minus sign, so I'll write here minus. And y2 value is e power minus x. So this you can write it as, what is the answer? Directly you can write 1 by 2 x e power x. Here minus sign is there, plus into minus becomes minus. Here power again exponential, both are same. So here 2x is there, here minus x is there. 2x minus x is minus x. So e power x by 4. So this is your yp value. So the general solution you have to write. So the general solution is always you have to write general solution. Y is equal to, what is the value? YH, that is complementary solution, plus the particular solution. So complementary function plus complementary particular solution. That is your answer. I repeat once again the whole problem. First we are going to find the complementary function. So here m square, auxiliary equation you can say, or otherwise characteristic equation you can say. So m square minus 1 is equal to 0. Finding the root. So m is equal to plus or minus 1. Roots are unequal. So the value of complementary solution is yc1 e power x, c2 e power minus x. Then what we are assuming? Y1 we are assuming it as e power x, y2 as e power minus x. Then Wronskian we are finding out. Once you are finding out Wronskian, we are finding what is u1 and what is u2. Then we are substituting in the particular solution formula. After that, we are getting the general solution, YH plus YP. So together this is the solver answer for the variation of parameters. Why we are using variation of parameters? It can be found out for undetermined coefficient, and it works for the wider forcing function. Thank you.